Hi guys, so I know a lot of you were having problems yesterday, so we're going to go through lesson number 1 together. I will upload it to YouTube and then try to link it to our Google Classroom, and fingers crossed that will work for everybody. So let me go through the note with you just like we would if we were in class, okay? Okay, you're gonna have to bear with me though, because you know, I have to hold and write. Okay, so the most basic parabola, y equals x squared. So the parabola is a graph of a quadratic function. Quadratic functions is what we were just working on. All those polynomials that you had to FOIL and factor, those are quadratic functions. So a quadratic function is any equation where the highest power of x in standard form is 2, okay? So x squared, 3x squared, anything like that, x squared plus 8, those are all examples of quadratic equations, okay? So what we're gonna do is we're gonna complete a table of values because I know how much you like that. So I know what x equals. I want to find out what y equals. So y equals -4, and I'm squaring that. So we're talking 16. So -3 squared, we're talking 9. -2 squared, we're talking 4. -1 squared, and we're just going to keep going. Okay, so I'm going to tell you that you will notice the numbers, because it is a parabola. Sorry, I'm getting out of focus. Just like class, I'm out of screen, right? So the parabola, guys, starts at a vertex, 0, 0 in this case, and we're going up on either side of the parabola as we move over. So when we graph this, and I'll just try to zoom out a little bit, I'm going to start at my vertex. So my vertex is 0, 0. And I don't have my magic pen here, so I'm sorry to disappoint you. When x is -1, okay, so when x is -1, y is 1. Okay, when x is -2, so when x was -2, y was 4. When x was -3, y was 9. When x was -4, y was 16. So this is half of my parabola, and I'm going to draw the same numbers on the other side. I'm going to make sure that I move over one space as I go. So remember, it's the same thing like when you guys were doing your slope, you used to run over one space and then rise up 1 or rise up 2. This time you're running one space, but your rise is inconsistent. You're following different steps. So this is basically what a parabola looks like. There are no straight lines. Okay, there are no jagged edges. It doesn't look like you're actually going up steps, okay, even though we will call it a step pattern later. So other key features, so coordinate of my vertex. So my vertex, and you guys probably should remember some of these things from grade 10. You did a whole unit on this. It would have been your last unit you did, but I know grade 10 was a long time ago for a lot of you. So a vertex is the spot where it changes direction, okay? So the vertex coordinates, in this case, 0, 0. The axis of symmetry, that is this line. Oh, sorry, you can't see. Sorry, that is this line right here that cuts the parabola evenly in half. So you have a mirror image. So it's symmetrical on one side and the other. So, and we say, where is that? Well, that is when x equals 0. So the optimum value, this is where we say, do we have a maximum or a minimum? This is our absolute lowest value we could possibly have. So our y value, we're looking at y values here. Y value cannot go any lower than 0, 0. So we say we have a minimum value of 0. Okay, so now it's asking us, what are our zeros? Zeros is a fancy word for x-intercepts, okay? X-intercepts. So are there any x-intercepts? There's only one, and it's at 0. We got a lot of zeros in this answer here. So, and it is at 0. This is the only place that this parabola crosses the line. So that's where we're going from it. The y-intercept, where does our line, just like when we did slope before, where does the line cross the y-axis? Right here. And guys, you guessed it, it is at 0. Now, step pattern, I did mention that a few minutes ago. What is our step pattern? So every time I go over 1, how many do I go up? I go up 1 in the first case. The next step, I go over 1, I went up 3. Then I went over 1, I went up 5. Over 1, up 7. This is a standard parabola. The step pattern is, so our steps equals 1, 3, 5, 7. And it just keeps going. See these little arrows? We know it goes on forever. Okay, so that's what we're going to keep doing. Flip your page over or follow along with me. And if you've already done this and you already understand it, you're amazing. But if you're struggling, we're just going to go through it and you're also amazing. Okay, so graph both the functions on the grid. Oh, sorry guys, my answers are already filled in. Oh, it's the wrong one. Sorry, here we go. So next sheet. Sorry, I skipped ahead on you. So looking at key features of another parabola. So here's another parabola. It's got a different stat pattern. You will notice compared to our parabola, the last one we did, it is the scale is the same. The scale is the same, but it is much more narrow. Okay. That's what we call a compression. So, oh, I'm sorry. That is what we call a stretch. It is a narrowed, stretched out parabola. Our vertex is moved. We have x-intercepts. Our y-intercept is over here. So we've just shifted this parabola and kind of changed what it looked like. And that's what we're going to be doing over the next few days. So some of this, I hope, will start to come back to you. But you know what? We'll go through it just in case it doesn't. So the coordinate of the vertex in this case again, and remember guys, the vertex is the point where it changes direction. We always include the x first. So x is at 3. And then we include our y value, and that is a -8. So those are the coordinates of our vertex. The equation of the axis of symmetry. So again, this is where we cut our parabola in half. Okay, so it is a mirror image on both sides. So that is our axis of symmetry. So x equals 3. Minimum or maximum value. This goes on forever, these parabolas. They're just going on forever. There is no maximum y value. There is absolutely a minimum y value. It doesn't go any lower than here. So it is -8, and that is a minimum. Guys, little clue here, and I'm really missing my magic pen, but equation of axis of symmetry, you will notice it looks like a 3, and this looks like a 3. They're the same. Optimal value and your y vertex point, they are the same. So if you know them, then you'll be okay to answering those questions. So zeros, and we said again, our x-intercepts. So the line intercepts the x-axis. Remember, this is our x and this is our y. So intercepts our x-axis at 1 and 5. So on my zeros, I'm going to write down 1 and 5. Guys, I will tell you that those are your factors. If you were going to factor this equation, those would be your factors. X plus 1, x plus 5. Okay? So, like if you can't remember, x plus 1, x plus 5. That's what that looks like. So this is what this equation, y equals in standard form, in factored form. So you could FOIL this now and get the whole equation for what this line looks like, okay? So y-intercept moving along. So here we have, where does it cross the y-axis? Right there at the 10. Now step pattern, here's the thing. We go over 1, we go up 1, 2. So our first step is 2. We go over 1, we go up 1, 2, 3, 4, 5, 6. Second step is 6. We go over 1, we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. Okay, and it just keeps going. You will notice our original step pattern was 1, 3, 5, 7. Okay, this step pattern is now 2. So 1 times 2, 3 times 2, 5 times 2. So we take our step pattern. This is the standard step pattern. And we multiply each step in here by whatever our value is. And I'll show you what that's going to be. We're going to go figure out those values pretty quick here. So this is how you calculate step pattern.